Hi, welcome to the Olympiad geometry. Let's continue our study of Stewart's theorem. Let's check this problem. Let I, O, G, H to be the incenter, circumcenter, centroid, and also center of triangle ABC. BC equals to A, C equals to B, AB equals to C. P equals to half A plus B plus C, that's half parameter R, and R are the radius of circumcircle and incircle. Proof 1, 2, 3, 4. Right? Basically, the first one is IA, IB, IC relation, and the second one is the distance from the incenter to the circumcenter, and the third one is the distance from the incenter to centroid, and the fourth one is from incenter to orthocenter. It just reminds us that we actually want to find a way to calculate a point, the distance of a point to the incenter, right? So we can, again, let's just review the Stewart theorem first, and then we can check out this problem. How can we generalize the problem? A, B, C, P. So AP squared equals to AB squared times PC divided by BC plus AC squared times BP divided by BC minus BP times PC. That's the Stewart theorem. Okay, so let's look at a case, a general case. That's in a triangle ABC. This is in center I. And on the plane, let's say there is a point P. If we know the length of PA, PB, and PC, can we find out PI? Okay, that's a problem, because if you look at all of these, the first one already got you that IA, IB, IC. That means the P is on the I point. So let's just calculate the PI. We know that I is the incenter. So we can extend the BI, intersect AC on point D. Notice that because BD is the angle bisector of angle ABC, so we actually know the ratio of AD to DC, right? Here is A, BC is A, CA is B, AB is C. So we know the actual length of AD and DC. Because we know the AD and DC, we know the length of AI, we know the length of IC, we can calculate for the ID. Right? All of this can be calculated. And once we know the length of ID, we know, because we know the length of BD, so we know the ratio of ID to BD. Also the ratio of BI to BD. And in that case, we just need to find out the length of PD. Once we got the length of PD, we know the length of PB, we can find the PI. Right? So the first thing is that we want to find the PD. Notice that PD squared in triangle APC, and let's look at the line PD, right? PD squared equals to PA squared times DC divided by AC plus PC squared times AD divided by AC times minus AD times DC, right? So because we know that BD is an angle bisector, so AB divided by BC equals 2 AD divided by DC equals 2 C divided by A, which means AD to AC equals 2 C divided by A plus C times the real length of that's a ratio, right? And so we got AD equals 2 C divided by A plus C times AC. The real length of AC is B, so that's BC divided by A plus C. Similarly, we know that DC divided by AC equals 2 A divided by A plus C. So we got DC equals 2 AB divided by A plus C. Right, that's the length of DC. So now we look at this term. BD squared equals 2 PA squared times DC divided by AC. DC divided by AC, that's A to A plus C plus PC squared times AD to AC. AD to AC, that's C to A plus C minus AD times DC. AD is this one and DC is this one, so we got B squared AC divided by A plus C squared. Right, now we know the PD squared, and we want to know ID, we want to know BI, because if we know the ratio of ID to BI, then we know, if we know the ratio of ID to BI, then we know the ratio of BI to BD, then we can calculate the PI, right? Notice that AI is the angle bisector of of the angle BAC or BAD, which means AB to AD, AB to AD equals to BI to ID. Which means BI to ID equals to AB to AD. AB is C, right? AD is this one. So BC to A plus C equals 2 A plus C divided by B. Okay, so BI to ID is A plus C divided by B, which means BI to BD equals 2 A plus C divided by A plus B plus C. And also we got ID to BD equals 2 B to A plus B plus C. Right. We got this, and yet we want to know the length of BD, so we can calculate from BD squared equals 2 AB squared. Actually, we have this calculation before, that AB times BC minus AD times DC, but let's just write it again. BD squared equals 2 AB squared times DC divided by AC plus BC squared times AD divided by AC minus AD times DC, right? A equals 2. Notice that AB to AC, DC to, actually we already have all of these, so let's just write it down. C squared times DC to AC. DC to AC is this one. So A plus C plus BC squared, that's A squared times AD to AC, that's C to A plus C minus ADDC. ADDC is B squared AC to A plus C squared. So this equals 2 AC minus B squared AC divided by A plus C squared. That's a BD squared. Okay, so for here, we got the BD squared, and we know BI, the ratio of BI to BD, and we know the ratio of ID to BD, right? So we can calculate the PI now, because PI squared equals 2 PB squared times ID to BD plus PD squared times BI to BD minus BI times ID, right? It equals 2 PB squared times ID to BD. Let's just write it down here. Plus PD squared. PD squared, we already got it here. Times BI to BD minus BI times ID equals to BD squared times BI minus BD. ID minus BI divided by BD and ID divided by BD, right? So it equals to PB squared times ID to BD. ID to BD is here, right? ID to BD. That's B divided by A plus B plus C plus PD squared. PD squared is this one, right? So PA squared times A divided by A plus C plus PC squared times C divided by A plus C minus B squared AC divided by A plus C squared. This is a PD squared times BI to BD. BI to BD, that's A plus C to A plus B plus C minus BD squared. BD squared is this one. AC minus B squared AC to A plus C squared times BI to BD. BI to BD, that's A plus C divided by A plus B plus C times ID to BD. So B divided by A plus B plus C. Right. We get this long equation here, and it equals to PB squared times B to A plus B plus C plus. Notice that these two terms, the production of these two terms, AC, are cancelled. So we got PA squared times A divided by A plus B plus C plus PC squared times C divided by A plus B plus C, and minus A plus C, just cancel one A plus C here, so we have A plus C times A plus B plus C, and we got B squared AC left, right? And minus, so we can extract AC out here, So we have AC, A plus C squared minus B squared divided by A plus C squared times A plus B plus C squared. And here we have A plus C times B. Right? So let's just look at these two terms. Okay, so this is minus, this is minus, so we can just extract a minus out. That means addition of these two terms. It's B squared AC divided by A plus C, A plus B plus C, plus ABC, this cancels, times A plus C plus B, right, times A plus C minus B divided by A plus C times A plus B plus C squared. So this one can be cancelled as this here. So we got A plus C times A plus B plus C, and we have on the top we have B squared AC plus A squared BC plus ABC squared minus AB squared C, right? A equals to A plus C times A plus B plus C, and we have these two cancels. ABC A plus C equals to ABC divided by A plus B plus C, right? So that means PI squared equals to PA squared times A divided by A plus B plus C plus PV squared times B divided by A plus B plus C plus PC squared times C divided by A plus B plus C minus ABC divided by A plus B plus C, right? Or we can just write it as A plus B plus C. A PA squared plus B PB squared plus C PC squared minus ABC. Okay, now we just calculate any point, the distance of any point to the incenter as a function of this point to the vertex of triangle, right? So let's look at the case, right? The case 1, when P is on I. P is on I. So when P is on I, that means Pi squared equals to 0. Right? That means we got 0 equals to A plus B plus C 1 over this times A times PA squared plus, oh, we can write as IA squared because PA is on I. So I squared plus B times IB squared plus C times IC squared minus ABC. Because this is 0, that means this is 0, right? Because A plus B plus C is something. Of course, this is non-zero. So we got AIA squared plus BIB squared plus CIC squared equals to ABC. Look at these two two equations here. This one and this one. They are the same, right? We just prove the first case. And for the second case, we want to calculate the distance between the incenter and the circumcenter. So let's just look at this one. The OI squared can be written as A1 divided by A plus B plus C times A times OA squared plus B times OB squared plus C times OC squared minus ABC. Right? Notice that OA equals to OB equals to OC equals to R, which means this equals to R squared minus ABC divided by A plus B plus C. Right. And here, let's do another thing. If we want to calculate, if we want to calculate the area of triangle ABC, what we can do here? We can have a incircle here, and we know that the area of triangle ABC equals to the area summation of triangle ABI and the triangle ACI and triangle BCI equals to R times half R times A plus B plus C. That's for the area calculation using the radius of incircle. And for the area calculation that use the radius of circumcircle, we can do things like this. Right, we have A, B, C here. And this is A, this is B, this is C. We know that triangle area ABC equals to half ABAC cos sine angle BAC equals to half BC sine BAC, right? This is O. We know that angle BAC equals to half angle BOC, which means R times sine angle BAC times 2 equals to A, right? R times sine angle BAC, that's a half of the BC, times 2, that's a BC equals to A, which means sine angle BAC equals to A divided by 2R. We bring it here. So the triangle ABC area can be written as ABC divided by 4R. So that means half R times A plus B plus C equals to ABC divided by 4R, which means ABC divided by A plus B plus C equals to R divided by, actually, A equals to half R times 4R equals to 2RR, right? Which means we have here can be rewritten as R squared minus 2RR. Okay, and just a look at the problem. We want to prove that IO squared equals to R squared minus ABC divided by A plus B plus C, R squared minus 2RR. We just prove it. And for the third case, we want to calculate the distance from the centroid to the in-center, right? It looks like a long calculation, but let's do it. Again, IG squared equals 2 1 over A plus B plus C times A times GA squared plus B times GB squared plus C times GC squared minus ABC. Right, so we want to know the GA squared, GB squared, and GC squared. And we're talking about centroid, right? So here. We want to calculate GA, GB, and GC. Notice that, let's say this is a DEF, right? Because AF to FB equals to 1. BC to DC equals to 2. So we use Mendeley's theorem on the triangle. Use Mendeley's theorem on triangle ABD and line intersection line FGC. Right, we have AF divided by FB times BC divided by DC times DG divided by GA equals to 1. Right, this is 1. BC to DC, this is 2. So we got DG to GA equals to 1 to 2. Right, DG to GA equals to 1 to 2. Which means if we know the length of AD, then we know the length of AG. That's 2/3 of AD. So what's the length of AD? AD is median of the triangle ABC. So AD squared equals to half AB squared plus half AC squared minus quarter of BC squared, right? A equals 2. Let's just write as this one. 2C squared plus 2B squared minus A squared. Right, that's a AD squared, which means AG squared equals 2 right, 2/3 squared times AD squared, which equals to 129 times this one, 2C squared plus B squared minus A squared. That's a AD squared. That's a AG squared. And we know this is a circulant symmetrical form, right? So we can simply write this one, IG squared equals 2 A plus B plus C 1 over this times A times GA squared. That's this one, 2C squared plus B squared minus A squared. And for the GB squared, we can directly write it, right? That's definitely 2A squared plus, because it's GB squared, so plus C squared minus B squared, right? And plus C times GC squared. GC squared should be 109 to a squared plus b squared minus c squared. And that's just this thing, and we still need to minus ABC, right? Minus ABC. So we extract 1/9 out, that equals 2. And this a plus b plus c, that's 2p. So 1/18p times 2a c squared plus b squared and plus 2b a squared plus c squared plus 2c a squared plus b squared minus a to the power 3 minus b to the power 3 minus c to the power 3, and also minus 9abc. Right. Just to look at this one and this one. They're the same. We just prove it. Right. They're the same. Now we want to calculate the final